Okay, application of integration we are going to do today. Now I am going to share my experience. That's all. Just I am going to share different problems where we are finding the difficulties. Just what we are going to do, and how I went started the class also. I am going to teach here only. Just how I taught the children, how the children. If you know that any other method better than this, you can also share with us so that we can learn from you. That's what I planned today. Nothing new. I am showing that everything you know that very well. Maybe different way of approaching the problem. Maybe you may see that, or the same way means you can give me any suggestions and anything I can accept it, and then I will implement in my classroom also. And then we start with the area as a definite integral. As you know that already, everything. The area bounded by the curve y is equal to f of x, and the x-axis and the two ordinates x is equal to a and x is equal to b. The two ordinates are the two vertical lines. Sorry. This is x is equal to this a, actually not written here. This is x is equal to a, the vertical line, and this is x is equal to b. So area bounded by the curve and the x-axis and the two ordinates, the vertical lines x is equal to a and x is equal to b. There's a blue color region is given by integral a to b f of x dx or integral a to b y dx. Okay, this is a definite integral. We know that already. This is the area bounded by the curve, x-axis, and the two ordinates is given by the integration symbol. A to integral a to b f of x dx. This proof and all I'm not going to explain here already. And then the same another y is equal. Sorry, I think it's not saved. I drawn everything. Sorry, this is x-axis. This is the curve. X is equal to f of y. X in terms of y, function of y alone. And then this is y is equal to this is c and this is d. We can have y is equal to d and this is y is equal to c. So the area bounded by the curve, the y-axis, and the two abscissas, y is equal to c and y is equal to d. So this shaded region, we call it as area bounded by area of the region bounded by the curve and the y-axis and the two abscissa, y is equal to c and y is equal to d, is given by integral c to d f of y dy or integral c to d x dy. We can write x dy. So modulus means it is a positive always. The area is positive. We can give modulus here x dx, x dy. This is another way of finding the region. And then I will go to different examples. First of all, let me share one example which we find in the board exam question. Okay. Actually, find the area, I think 2015 or 16, I'm not exactly remember. This region, this question was very much find difficult. The students find it very difficult. I don't know. This two curves, modulus that is absolute value function. Y is equal to modulus of x minus 1. Find the area of the region bounded by the curves. Y is equal to modulus of x minus 1. And y is equal to 3 minus the modulus of x, or 3 minus the absolute value of x using integration. So this area, Radhika ma'am, do you remember which year? I think 16 or 15, I'm not remember.
2015, sir.
2015, I think.
Yes.
Mr. Kumar batch, that batch.
Yes, sir.
It was a very that time the graph itself, the board exam. If we draw the graph perfectly, sketch the graph means I remember that is 4 marks for awarded.
6 marks
Yeah,
given.
6-mark question, and then for only the graph it is 4 marks given, and the area correctly if you written the 2 more marks added. Only for graph itself they have given awarded 4 marks. So it was At that time, it was a difficult question only, but because we did not come across such a question, the two absolute value function and intersection region, that bounded region also. That's why I wanted to share this question now. And then I will show the graph of this function. I have drawn the graph already. How to draw I have took how I drawn the graph by taking the values, sketch the graph, y is equal to modulus of x minus 1. I took x value 0, y values, this left side and right side, I have written the values of x and y. Just I plotted the points. This way is the best way I find for the children to sketch the curve. Because that year, almost my students, everyone sketch the curve, but they find it very difficult in finding the area of the region. For that also, it's taught them some techniques how to find the area correctly by counting the squares. By counting the squares in the graph. So my student always used to draw the graph in the graph paper only, this diagrams and all. Mostly what I do, even the classroom, they used to bring the sheets, graph sheets to the classroom. When I teach application of integration, I used to bring ask them to bring the graph sheets, and then I insist them to draw every diagram, the graph in the graph paper only. And then after that, I cut the graph paper the particular size, and then they will stick it in the classwork. The classwork is normal notebook, ruled notebook, but I ask them to bring the graph sheets, and then they will draw it in the graph, and then they will cut it and paste it in the classwork just against the problem where they work out. So they used to draw in the graph sheets. That's what method of teaching. I will do like that only, because, and also sometimes I used to tell them to check the answer by counting the squares in the region. So for example, this yellow region, you see that if we count them, you will get 4 square units, because 1 full square is there and 6 half squares are there. 6 half squares, it is 3 full squares. 3 plus 1 full square is already there in the graph, that region. If you count them, you can find out. So totally 4 square units is the area of the region. Without any calculation, we can find out it is 4 square units. So whether we get the answer 4 square units means your answer is correct, we can satisfy ourselves. Such a way I used to tell them. That year, what happened? Many of them they sketched the graph. Yes,
sir.
sir.
Good evening, sir.
Tell me, sir.
So with the help of coordinate geometry also we can get, sir. If they don't.
No. By checking the answer, for checking the answer.
Okay.
We have to do only by integration. We have to calculate only by integration.
Now,
Finally,
for this diagram,
I
am telling, sir. For this diagram.
The graph only I'm talking about. The graph.
Yes, sir. We can get what is this 1, 0, 2, 1, 0, 3, like that.
Yeah.
Then it's a rectangle, no? So we can get length into breadth.
Yeah, yes, of course.
For cross checking, sir. Only for cross checking.
Yeah, cross checking. Yeah, cross checking, we can do that. Anyhow.
Length will come 2 units.
And also, but yeah, like that also. Yes, sir. Cross checking only. Anyway, you can. But the sketching the graph, they find it very difficult, sir. While we correcting the paper, you see that many of them they don't able to draw the graph at all. I don't know which is school, which is paper. We don't know what we corrected. So out of 20 papers, if we correct one, maybe one of the graph may be correct like that. And then we felt very bad because we are ready to give the marks for graph. For one graph, one absolute value function, they asked us to give 2 marks. If another one is correct, means another 2 marks. Mostly that y is equal to modulus of x minus 1 is almost many of them got the correct answer. But another graph, they did not get it. So even 2 marks, they unable to get because they do not know how to sketch the graph. Many students, they do not know. Some children, they only intersection point they are making, and then they are not able to sketch the graph. Somebody, they have drawn the parabola. Like that, we are finding that when you are correcting the papers, we found very difficult. And also the children are, they did not get marks at all for this question. Very few out of 30 or 40 papers, only one of them drawn correctly the graph. And then also that in the calculation, they did a mistake, correct answer. They are unable to check the answer also. These are the difficulties we found in the correction paper. Even our children, or many of them, did not draw properly, but some of them, Many of them they told just sir, we don't know correctly calculation we did not do properly, but we got the answer 4 like that I wrote. Then I drawn the graph correctly, and then just we know that 4 square units, but we are not able to arrive at the correct answer while we calculating like that they were telling. All these comments we have got. That's why I wanted to discuss this question especially. It is an easy question only, but sketching the curve, if we insist them and then take the values of x and the values of y, and then if you plot them, plot the curve, and then finding the region bounded by the two curves, and then shade the region. So in this way, if we teach them, definitely they can draw the sketch the curve at least correctly. Accordingly, they make the answer also. And then by using integration, how to find the answer for this. So x is equal to -1. The whole region is between x is equal to -1 and x is equal to 2, the two ordinates. So, and then also we cannot do like that. X is equal to -1 to x is equal to 0. So area under the line y is equal to 3 plus x. This region will come. Maybe, yeah, this region will get, that is, yeah, this region area, the integral -1 to 0, area under the line y is equal to 3 plus x dx. And then next area is 0 to x equal to 0 to x equal to 2. And then area under the line y is equal to 3 minus x, because the graph I divided into 2 lines like that. The model is for this area I will get it after this. So this 1, 2, 3, 4, 5, this pentagon value, pentagon, I think this area will get, and then this unwanted area you have to remove. So -1 to 1, area under the line y is equal to minus of x minus 1, and from integral 1 to 2, x is equal to 1 to x is equal to area under the line x minus 1 dx. This region, if you subtract, you will get the region which is required, area of the region which is required for you. So that I wrote this. Area of the bounded region is integral -1 to 0 3 plus x dx plus integral 0 to 2. I hope so. 0 to 2, area under the line or 3 minus x, y is equal to 3 minus x dx, minus -1 to 1, minus of x minus 1 dx, and then again subtract 1 to 2, area under x minus 1 dx. That's what. So these are the 4 integration, and then you have to find the values of integration. After the finding the integration, you can do like that. 3x integration is 3x plus x squared by 2. So just I work out here. -1 to 0. They are finding a lot of difficulties in that minus plus all this calculation. Very carefully they have to do. 3x minus x squared by 2 and 0 to 2. Minus into minus plus we can write. So x squared by 2 minus x minus 1 to plus 1 minus of x squared by 2 minus x integral 1 to 2. Yeah, it is equal to, if we substitute 0 here, it is 0 minus of -1 if you get -3 plus 1 by 2. -3 plus 1 by 2 is -5 by 2. Right? -3 plus 1 by 2 minus 5 by 2. Okay. Plus 6 minus 2. 6 minus 2 is 4 minus 0. Then plus this 1, if you apply 1 by 2 minus 1, it is minus half, minus of 1 by 2 plus 1. So 3 by 2. Then a minus of 1 if you applied, and then minus 1 you applied. Then here this minus 1 by 2 minus 1. Sorry, 1 by 2 minus 1. Sorry. First apply 1 here. My 1 by 2 minus 1, it is minus half. So 1 by 2 minus of minus 1 plus 1. 1 by 2 plus 1. 3 by 2 minus 3 by 2. Am I right? I think 4 by 2, it is 2. Minus 2, 0. Minus of 1 by 2 minus 1, it is minus half. So it is 5 by 2 plus 4. Then it is minus 4 by 2, it is minus 2. It's 2 minus 2, 0. Plus half minus half. Sorry. So plus 5 by 2 minus 5 by 2 cancel. It is 4 square roots. So this part is a very difficult part. They may make mistakes here. And then I don't think any other short way for this finding the value of the region. So this part they find it very difficult that time 2015 exam. That's what I wanted to share this question to you. So many of them wrote the correct answer 4 square units, but all the steps are not explained very well, and then steps are not there at all. So even graph also they did not draw properly, but the answer is 4 square units they wrote. Some children like that different way of answering we have found that. Yeah, this way. Anything is anything comment? Is there anything or any better way of teaching this problem? Anyone we can share it. Please, I will accept and then I will implement in this in my classroom. So any better way of approaching this problem? Any teacher can just come forward, please tell us.
No, sir. This is the way even I explain.
Yeah, yes, fine. Thank you. Because it takes a lot of time also, but anyhow, they have to do quickly. So sketching the curve, I think it is the best way to make so many points. We take many points. If they meant they will not do mistakes, especially in parabola and all. Taking a lot of points, minimum 5-6 points. If you take and plot, and then if you do that, you can get the curve. Naturally, you get the curve. That's why I felt. Arun Pandin sir, welcome sir. And then,
Namaste, sir.
Welcome sir. So any other way, if you find it very easy, then you can share it with us so that we can also take it and then we can implement to the children. I don't think so. It is. I think it is a good way of explaining by drawing the curve and then finding the each and every region. There are around 4 regions. 2 regions we have added and then 2 regions we have subtracted, so that we'll get the entire yellow color region. So, next one more. It's a different question. How to do that? Sketch the graph of f of x is equal to absolute value of x minus 2 plus 2 when x is less than or equal to 2 and x squared minus 2 and x is greater than 2. Is a x squared minus 2 is a parabola, but when x is greater than 2, this is the answer. And when x is less than or equal to 2, a modulus of x minus 2 plus 2. Evaluate integral 0 to 4 f of x dx. So from 0 up to 4, we have to evaluate the function. What is the value of this integral represent in the graph? What is the value of the integral represent in the graph? So graph sheet is here, and then y is equal to, if x is less than or equal to 2, modulus of x minus 2 plus 2. Okay. So when x is less than or equal to 2, suppose if it is x is greater than 2 means it is x squared minus 2. So y is equal to x squared minus 2 when x is greater than. Okay. So let's take the x value and the y value. Let us see the graph. How it is. Sorry, the pen is not ready. So if I take x is equal to 0, then 2 plus 2, 4. We are getting 4, right? X is equal to 0 means it is 4. When x is equal to 1, 1 minus 2 minus 1 plus 3. X is equal to 2, it is 2. Yeah. Then because as less than or equal to only we are taking. So minus 1 if I give. So 3 plus 2, 5 you get. And minus 2, minus 4, plus 4, 6. Like that it goes values. Here in the graph y is equal to x squared minus 2. Take the values of x equal to 2. Greater than 2. We have to take values greater than 2. 4 minus 2, it is 2. And then if it is 3, 3 squared, 9, 9 minus 2, it is 7. Suppose if we take 4, up to 4 it is required because find the value of 0 to 4. For 16 minus 2, 40. 4 it is 40. Yeah. I think it is enough. I think if we take 5, 25 minus 2, 23. So it's a very high value. So anyhow, so let us draw the graph here. And then I take values here. So the one part I'll take more. Okay. Zero, 1, 2, 3, 4, 5, 6. Let us sketch the graph. Okay. Now I plot the points and 0, 4. 0, 4 is this point. Take another color. And then 1, 3, 1 here, 3 here. And 2, 2. Okay. That's all. It is, and then minus 1, it is 5. Minus 2, it is 6. So graph is going like this. Okay. Next, I think it is a parabola. Y squared equal to y is equal to x squared 2 comma 2, 3 comma 7. 3 comma 7 is here. This point is here. And 4 it is 14. 4 it is 14. And then the graph will 5 it is 23. It is go like that. So the area lies between, if we draw the line, x is equal to 0 is a y-axis and x is equal to 4. X is equal to 4 is this line. Yeah. So the region, bounded region is here. It is what's this region is. Yeah. So it is not comes under the single curve, so that it is this is y is equal to minus of x minus 2 plus 2. This one we can write this as, because when it is the negative, when x is less than or equal to 2, x minus 2 is minus of x minus 2, right? Minus of x minus 2, actually, sorry. Minus of, sorry, plus 2. So it is 4 minus 6, actually. Y is equal to 4 minus, this is the line. Y is equal to 4 minus 6. And this is actually this parabola, it is y is equal to x squared minus 2. So when you remove the modulus, it is 4 minus 6. So integral 0 to x is equal to 0 to x is equal to 2. When x is equal to 2, divide this area, actually this area, half of this area. This area is integral 0 to 2, area under the line 4 minus 6 dx, and 2 to 4, area under the parabola, x squared minus 2. If you add both, you will get the entire region. That is what we can write. Integral area of the region is equal to integral 0 to, sorry, integral 0 to 2, area under this modulus function y is equal to 4 minus 6 dx, plus integral 2 to 4, area under this x squared parabola, x squared minus 2 into dx. So if you find the, I think finding the answer is easy. 4x minus x squared by 2. This is all a parabola straight line, easy to find the answer integration. Only in the circle problem, only difficult. Plus x cubed by 3 minus 2x 2 to 4. Yeah, we substitute this. So 4 into 2, 8. 8 minus 2, 6 minus 0. And then 4 cube, 64 by 3 minus 8. 64 by 3 minus 8 minus of 2 cube, 8 by 3 minus 4. How much? 6 minus 4 is 6. And then 64 by 3, 24 minus 24, 40 by 3 minus 12, 8 minus 12 minus 4 by 3 plus 4 by 3. So 44 by 3 plus 6, 18, 18 plus 44, 52, 62 by 3. Yeah, it is 3 times 6, 18. 18 plus 44, 52, 62 by 3 square roots is the area. Okay. So this is somewhat a difficult, not difficult, but absolute value function and the parabola together. Okay. So when x is less than or equal to 2, the values are different. That is absolute value function, half of the graph you have to draw. And from x is greater than 2, and also you got to the graph will goes like that. So you have to evaluate the integral. The question is evaluate integral 0 to 4 f of x dx. That's given. So otherwise it is unbounded region. So integral 0 to 4 integral evaluate f of x dx. So only to 0 to 4. So this is a region bounded by the area 62 by 3 square units. Yeah. Is there any comment on this or anything to be explained well, and then or any other way we can do this? Anything else you can share with me? with us.
Fine, sir.
Thank you, ma'am. Thank you. I think otherwise we'll go for a. So I felt that if they draw it in the graph, it is better. So they can get the correct shape also, and then exact region they may get it. That's why I insist the children to. Next question is sorry. Find the area. I'll go to next question. Area of the region bounded by the curve. Y is equal to x into 4 minus x, the x-axis, and the lines x is equal to 0 and x is equal to 5. X is equal to 5. Find the area of the region bounded by the curve. Y is equal to x into 4 minus x or 4x minus x squared. Both are same only. The x-axis 4x minus x squared we can write. Y is equal to 4x minus x squared also we can do. And the x-axis and the line x is equal to 0 and x is equal to 5. That is the x-axis. Sorry. X-axis, x is equal to 0, the ordinates x is equal to 0 and x equal to 5. They're bounded by the region. So we are going to switch the graph. This. So here y is equal to, sorry. What is this? Y is equal to 4 into x minus, sorry, 4 minus, sorry, what is it? 4x, 4 into x into 4 minus x, sorry. Or there is a 4x minus x squared. So better we can take the values of x and y. If x is equal to 0, it is y is equal to 0. And x is equal to 1, 4 minus 1, 3. If x is equal to 2, 8 minus 1, is x is equal to what? 4 into 2, 8. 8 minus 4, it is 4, right? And x is equal to 3, 12 minus 9, it is 3 again. X is equal to 4, 4 4 16, 16 minus 16, 0. 4 minus 4, sorry, 4 if you get x equal to 4 means it is 0. 4 4 16 minus 16, 0. So if it is 5, because 0 up to 5, we have to take minimum at least. 20 minus 25, it is minus 5. Am I right? If we take the values, or that is different way it's coming. And 6, if we take 4, 6 are 24. 24 minus 36, it is minus 12. So it will go down. So let us have up to these values. Suppose if we take minus 1 here, what happened? Oh, minus 4, minus 1, minus 5. Yeah. Minus 1 also it is minus 1, 4 into minus 1, minus 4. Then minus 1 whole square is 1. Minus 5 only. Anyhow, so this is 1, 2, 3. So little bigger it is better. and then -1, -2. Two, 3, 4, 5, 6. So -1, -2, -3. Goes up to okay. Now, if you plot the points, we take different color. 0, 0, 0, 0. Then 1, 3, 1, 3. What happened? Okay. 2, it is 4. And 3, it is 3 again. And 4, sorry, something points. 4, it is 0. And 5, it is it -5. 5, it is -5 here. And 6, it is -12. Maybe somewhat will go like that. -12, it is go far. Maybe it is coming like that. And then -1, it is -5. So the curve is coming like that. And then we have to draw the ordinates. X is equal to 0, it is there already, y-axis. And x is equal to 5. X is equal to 5. Bring the scale and better. It's a line x is equal to 5. Sorry. And the x equal to 0 is there, but now it is a region bounded by the curve. X is equal to 1, the x-axis. I think, sorry, what is that given? X-axis, x is equal to 0, x is equal to 5, and the parabola, that y is equal to 4x minus x squared. So, which region? So, this region, may I show it? This is the x-axis and the parabola between the x is equal to 0 and x is equal to 5. Also, I hope this is the below the x-axis also. This region also, it is comes under this region only. Am I right? I think so. So these two regions also bounded by the curve x-axis and the lines x is equal to 1, x is equal to 0, and x is equal to 5. So the area of the region is we have that below the x-axis means you have to put a modulus symbol because you go negative value. So whenever negative value comes also, you have to take it as positive. You have to use absolute value function. So integral 0 to 4 area under the parabola, that is y is equal to 4x minus x squared. And then again, this also under parabola only, but 4 to 5, integral 4 to 5 area under the curve at the parabola, but it is under modulus. That's all, because otherwise it will be subtracted from the area. So area under this curve So area of the bounded region is equal to integral 0 to 4, that is 4x minus x squared dx plus integral 4 to 5, the same but under modulus. Otherwise x squared minus 4x also we can write. Otherwise 4x minus x squared under modulus is the area of the bounded region. So we can calculate this area by using integration. This is what somewhat different because area under below the x-axis, so it will be negative answers we may come. So we have to take it absolute value function because area is always a positive quantity. Therefore, we have to take positive values. So we have to put under the modulus. So 4x squared by 2, the integration, minus x cubed by 3, 0 to 4, plus is modulus integral, there is a 4x squared by 2, minus x cubed by 3. It is 4 to 5. It is under modulus effort. So 4 into 2 into 16, 32 by 32 minus 64 by 3 minus 0. That is 0 is neglected. Plus 2 into 2550. 2 into 2550 minus 125 by 3 by cube minus of by using 4. Sorry. For 32 by 3. So 32. Sorry. 32 minus 64 by 3. So then we can 150 minus 125. It is 25 by 3 because these two things get cancelled. This is minus of and this is plus of. This will be cancelled. Oh, sorry, it is under modulus, no? Very sorry, I myself doing mistake. So here, sorry, 76 minus 64, 32 by 3. This is under modulus. Whatever it is, consider modulus. 150 minus 125. 25 by 3 minus this 76 minus 32 by 3. All right. So here it is 25 minus 32 minus 7 by 3 plus 7 by 3. So 32 plus 7, 39 by 3. It is 13 square units is the answer. 13 square units is the answer. So we may check that the graph also approximately the 13 squares are there, or 13 square units coming. Maybe half squares and the full squares. I did not draw a proper graph actually. So if you count that, it maybe you will get 13 square units or full squares. Almost 3/4 of the squares and all there. If we count all of them, we may get 13 square units. Roughly, approximately, we are getting the 13 square units. It's the area of the region bounded by the curve, and it comes below at the x-axis. So, any question? Anything? Is there any way of explaining this in another way? You can share with us. So 13 square units is the area of the region. Okay. So let's go to next question or different.
Yes, sir. We can go to the next one.
Yes, ma'am. Thank you. Find the area bounded by the curves. Two curves. That is two of them are maybe a little bit beyond the syllabus we are taking anyhow, but just to because the teachers said all we cannot do the simple problems. That's what I was selecting that those problems. You're all teachers, also you know everything very well. But anyhow, just I wanted to different experience will have like that. Y is equal to 6x minus x squared and y is equal to x squared minus 2x. So just we can share this 6x minus x squared and x squared minus 2 parabola we are going to draw, and then the area bounded by the two parabolas. I'll draw the. Let me take the values first. Okay. So y is equal to 6x minus x squared. Y is equal to 6x minus x squared. So x and y 0 if we take 0 minus 0 0. 1 if we give 6 minus 1 it is 5. 2 if we give 12 minus 4 it is 8. 3 6 3 are 18. 18 minus 9 it is 9. 4 24 minus 16 it is 8 again. Right, 5 if we take 30 minus 25 it is 5. Again coming back. And the 6 if we take it is 36 minus 36 0. And the 7 if we take, I think it is going like that. 642 minus 49 minus 7. If it takes up minus 1, minus 6, minus 7. Okay. Minus 1 also minus 7. Some if we take the long values only, we can get the idea of this one. And y is equal to x squared minus 2x. So if I draw in this page so that you can easily plot the point. That's why I'm drawing here. That's what. So x and y. If we take x is equal to 0, it is 0. And x is equal to 1, 1 minus 2, it is minus 1. If it is 2, 4 minus 4, 0, 2 comma 0. If it is 3, 9 minus 6, it is 3. 4, 16 minus 8, it is 8. It is 5, 25 minus 10, it is 15, it goes up. Suppose minus 1, if we take, what happened? Plus 1, plus 2, 3. Minus 1, it is 3. And the minus 2, if we take 4, 4 plus 4, 8. Okay. Let us have much picture. I think the graph just below maybe. One, 2, 3, 4, 5, 6, 7, 8. Okay. X-axis not necessary. Y-axis only we need more values. 6, 7, 8, 9, up to 9 I think is 10. So minus 1, minus 2, minus 3. Okay. X value x is equal to 0, it is y is equal to 0. 1, 5. 1 it is 5. And 2 it is 8. And 3 it is 9. 4 it is again 8 coming. And 5 it is 5. 6 it is 0. Okay. 7 it is -7. So somewhat here go down. It can have -7 means here. And then here -1 it is -7. -1 also -7. Okay. So the graph of the curve goes like this. Sorry. The freehand drawing is very, yeah, this curve. And then next curve is 0, 0. I'll take different color. Maybe I take this 0, 0. 1, -1. 1 -1. And then 2, 0. Yes, 2, 0. And 3, 3. 3 here, 3 here. And 4, 8. 4, 8 here. Okay. And the 5, 15. It means it goes very high. Somewhat here, maybe. And then -1. -1, it is 3. Okay. And -2, it is again 8. So the curve, we are getting that parabola. It's the parabola we are getting. So the area bounded is very easily visible here. The area bounded by the this one. So area bounded by the two parabola is very clear. That's the question, I think. Area bounded by the curves, two curves. So below the x-axis also a region is coming here, so that you can use modulus. So between which ordinates it is coming? That's what we have to check. It is 0 to I think this is sorry, this is 8 only. This is 8 only. It's 0 to 8. 0 to 4. This ordinate is 0 to 4. And then 0 to 4 area under this curve. This curve is y is equal to 6x minus x squared. And this curve is y is equal to x squared minus 2x. So we have to draw between the x is equal to 4. Sorry. This is line x is equal to 4. X is equal to 0, x is equal to 4. Between x is equal to 0 and x is equal to 4. What to do? How to find the area of the region? Integral 0 to 4, area under curve 6x minus x squared. Okay. Then we have to subtract under the x-axis. So then what happened? This curve, how to do that? That's what my question. Integral. So 4x minus x squared minus 2x. Yeah? X squared minus 2x. That is also what? From 0 to 4, because this curve also starting from 0 up to 4. So the finding the area of the curve is the area of the required area integral 0 to 4 66 minus x squared into dx minus integral 0 to 4 x squared minus 2x into dx. So both are same limit so that we can come under one integration. 0 to 4, 6x minus x squared minus x squared plus 2x. So 8x minus 2x squared. Yes, ma'am. 8x minus, because minus of x squared minus of minus 2x plus 2x. So 8x minus 2x squared. The calculation part is very easy here. 8x squared by 2 minus 2x cubed by 3. So 0 to 4. Very simple, we can calculate. So that it is 4 and it is, so 4 into 4, 16. 16 into 464 minus this 4 cube. 64 2 into 128 by 3. Yeah? This comes under modulus. That's very important because everything comes under modulus. 2x cube by 3. 4 cube. So 128 by 3. Any of the answer will come positive only. 196 minus 128. So 64 by 3 square units. 64 square units is the area of the bounded region. So this area, because here it is a 0 to 4 area under this curve y is equal to 6x minus x squared, and also minus 0 to 4 because the below also coming, therefore it is you take modulus, and then x squared minus 2x, so that you will get the entire region. These are all somewhat difficult questions to find the area of the region. Have you got it?
Yes, sir.
Yes, ma'am. Thank you. So that
Yes,
I
sir.
can go to next question. So like go one more question. Yeah, this was somewhat interesting question. Find the area bounded by the curve y is equal to x into modulus x. X into absolute value of x. The x-axis and the ordinates x is equal to -1 and x is equal to +1. X is equal to -1 and x is equal to +1. How to do that? Go for that. X is equal to x into y is equal to x into absolute value of x. Or we can write when x is less than 0, and x is modulus of x is minus x. So y is equal to, sorry, not y squared. Y is equal to minus x squared when x is less than 0, and y is equal to x squared when x is greater than or equal to 0. Yeah. When x is equal to greater than, so it is, we can split this and the two parabola actually. Y is equal to minus x squared is facing downwards, and y is equal to x squared is facing upwards. So that I think I have drawn the graph for it. Oh, it's not saved. I have drawn all the graphs. Yeah, the graph that I have saved anyhow. I will draw this again. I already drawn. I don't know how it is went on. I drawn the graph for this question especially. I don't know how it is gone. It suddenly disappeared. I don't know. Okay, let us write again. This graph y is equal to minus x squared. Sorry. I'm sorry. Okay. Now y is equal to actually minus x squared when x is less than 1, and here y is equal to plus x squared. Actually, the question is in between minus 1 and plus 1, x into modulus of x. X into minus x, it is when x is less than 0. And x is greater than 0 means it is plus x squared. Okay. So x, y will take 0, doesn't 0 will take 0 is 0, and the minus 1, if it is equal to minus 1, it is minus 1, am I right? And x is equal to minus 2, it is minus 4. X equal to minus 3, it is minus 9. And here y is equal to x squared means 0, 0, x and the y. 0, 0, 1, it is 1, 2, it is 4, 3, it is 9, like that goes. So here when it is minus x squared, it goes down. So let us plot the points. Let us see how it is coming. So 0, 0, minus 1, minus 1, minus 2, minus 4, and the minus 3, it is minus 9. And here the graph is coming like that. When it is x is greater than 0, x is equal to 0, 0, 1, 1, 2, 4, and 3, it is 9. Yeah, graph maybe like that is going. So we need the value only to calculate from minus 1 to plus 1. X is equal to minus 1 to x is equal to plus 1. Yeah. So we have to draw the ordinates x is equal to minus 1 to plus 1. So x is equal to minus 1 line. And this is x is equal to plus 1 line. Yeah, so between this x is equal to minus 1 and this is x is equal to 1. So between this line and bounded by the curve and the x-axis. So that means here where it is coming, which area? The area is this. So the pink color I am shading. So this area is a bounded region. Okay. This area is a bounded region. So while calculating this area, we have to use what? Modulus symbol. So -1 to 0, one region, plus 0 to 1 is another region, because modulus symbol separates the two integration. So area is required, sorry. So area is equal to, the required bounded region is equal to integral -1 to 0. So minus of x squared into the x. Or you can put modulus below the x-axis, better to put modulus. Integral 0 to 1. So x squared dx. So minus x cube by 3. So modulus 0 minus 1 to 0. Plus x cube by 3. 0 to 1. Okay. So what happened now? 0 by 3, 0 minus of minus 1. Minus 1, if you put minus 1, x cube is minus 1. Minus of minus 1 plus 1 by 3. Right? 0 minus of minus 1 if it's right, minus 1 whole cube by 3. That is plus 1 by 3. Modulus plus here 1 by 3 minus 0. So plus 1 by 3 plus 1 by 3 is equal to 2 by 3 square. 2/3 of square root. That's all. 2/3 of the 1 square square centimeter, I think, is the area of the region. It's very small, 2/3. Yeah. So the curve, I have not properly drawn the curve perfectly. So you have to draw the curve perfectly so that it is not half square. So less than the half square, it is less than the half square will come. So that 2/3 of the 1 square centimeter is the area of the bounded region. These are the questions I wanted. One more question I wanted to share. One more question I wanted to share it, but I have typed in that I don't maybe one more question I wanted to add. Maybe I'll write it as it. Area of the region. Find the area of the region. Maybe I'll write it here. Sorry. Set of all x comma y. Just such that now recently you asked me that maybe Sagodya school paper 3 minus 4 into modulus of x, comma, and x squared plus y greater or equal to 0. So find the area of the region of the two curves. 3 minus 4 into modulus of x and x squared plus y, it is greater or equal to 0. So these are the two curves. Okay. When you draw the two curves, somewhat maybe we find it very easy to. Somewhat different question. This is a different question they asked in the now Sagodaya school paper, common paper. It is Sagodaya school's cluster paper. I think they asked this question, and then. No, not. Yeah, let me draw this. Thank you. Okay. Okay, the curve is y less than, sorry, y less than or equal to, so 3 minus 4 into modulus of x. So if we take the values of the x and the y, y less than or equal to 3 minus 4 into modulus of x. It's a curve. So x and y will take values. So that is not. Yeah. So if it is 0, it is minus 1. Am I right? Sorry, sorry. If it is 0, it is 3. If it is 1, 3 minus 4, it is minus 1. If it is 2, 3 minus 8, 3 minus 8 is minus 5. If it is 3 minus 12, 3 minus 12 is minus 9. If it is minus 1, 3 again minus 1 is also what? Minus 1 only. Minus 2 also minus 5. Yeah. Minus 3 also minus 5. So plus or minus 1, you can type back the value. And here another curve is x squared plus y greater or equal to 0. So that is x squared plus y equal to 0 if you take. Y is equal to minus x squared. So if you take 0 here, 0, 1, minus 1, or plus or minus 1. Plus or minus 1, it is minus 1. Plus or minus 2, it is minus 4. Whatever it is. Plus or minus 3, it is minus 9 for this also. Alright, sir. So how to draw the graph? So that is timing, of course. I have drawn and kept the graph, but I don't know. Unfortunately, it is how it is disappeared. I am not sure. So 0, 1, 2, 3, 6, minus 1, minus 2. So the first curve 0, 3. Yes, I'll take some other 0, 3, 1, minus 1, 1, minus 1, and the minus 1 also minus 1, 2, minus 2, 5, minus 5, and minus 2 also minus 5, and 3 it is minus 9, minus 3 also it is minus, plus 3 also minus. So graph is a line. That's all. It's a straight line, sorry. And then the curve is x is equal to 0, y is equal to 0, plus or minus 1. This is another curve. So 0, 0, and then 2 plus or minus 2, minus 4. Minus 4, sorry, here minus 4. And a plus or minus 3, it is minus 9. Okay. Again, joining here. So the graph is like that. Sorry. This comes outside and cutting here. So that, so this is the region actually. So this is the region you are going to find out. So graph is somewhat I have drawn, but I am not perfectly drawn here. Yes, this is a modulus function actually, absolute value function. This is a straight line. Is that looks like that is coming. So how to find the area? So area of the region is minus 1 to 0, or you can both side it is symmetric. Both side it is symmetric, so that you can find the 2 times n is equal to just I'll explain 2 times is the time up, I think 2 times area under this 0 to actually it is a when x is equal to y is equal to 0. If you put y is equal to 0 here in this curve, we will get the x value is 3 by 4. X value is 3 by 4. So this point is where the intersection graph is 3 by 4, 0. So integral 0 to 3 by 4 area under the line 3 minus 3 plus 4x. 3 minus 4x. 3 minus 4x. Plus area under the curve under modulus. You have put under modulus. That is what is called 3 by 4 to 0 to 1 area under the parabola, and the 3 by 4 to 1 that area under the parabola to be subtracted. So that's the area we can find out. So this is somewhat difficult questions only that the time of the students may find difficult. So that if they sketch the graph correctly by using the scale and then plotting the points, they may find it the answer also correctly. Integration will come correctly. If they made any mistake in drawing the curve, it will be difficult. I think I have tried my level best to explain how I taught in the classroom. That's what I shared my experience in the classroom only. Even this question also we have discussed in the classroom because it's a Sabodaya school paper, recent school paper. So I don't know what type of, this is a 2000 all not there in the syllabus they're telling, but it is also they are asking. I don't know what level, up to what, there is no boundary for this in this chapter. So we have to teach them all so that they can do it any question, any type they ask.